Okay, in this section we're going to be solving trig equations. And this is a really important section for those of you going on to calculus, because you might have to do a calculus operation, and in the end you may have to solve something like this to finish the problem out. So it's really important to understand how this section works. So what this is saying is I have cosine of some angle, and the angle I got to find has got to equal square root of 3 over 2. So I want to find an angle between 0 and 360 that makes this statement correct. So one way of getting an angle is by looking at your table that was provided in the previous section. In that section we talked about how sine, cosine, tangent, they all come off of the unit circle, and we have the table of values here. If I want to solve this equation, what I do is I'm first going to look at square root of 3 over 2. I'm going to find that on the cosine column of my table. So I go down the cosine column, and here it is, square root of 3 over 2. I want to find the angle that's associated with that, and that's going to be 30 degrees. So I know that x is going to equal 30 degrees. That's going to be one of my answers. Again, this here says that we want to find all angles between 0 and 360 that make this true. So we want to see if there's any other possible solutions for this. So here is a unit circle, and our angle was 30 degrees. So right here I have an angle of 30 degrees. And if I looked at that point on the unit circle at 30 degrees right here, here's the y value, 1/2, and here's the x value, square root of 3 over 2. So technically the point that I have there is square root of 3 over 2 and 1/2. That's one point on the unit circle. So the question is that the only place where I have an x value of square root of 3 over 2? And the answer to that is going to be no. Right below it, right down here, there's another spot down here, and this is also square root of 3 over 2, because remember, cosine's positive in the first and the fourth quadrants. Now this, of course, will have a negative y value there that I'm not concerned about. The main thing is I'm noticing here that I have another spot on the unit circle that's square root of 3 over 2. So now the question is, what is that coordinate? Well, this angle right here would be 30 degrees. So going this direction is 30, and going that way is 30. Now technically this is going to be negative 30, because I'm going down that direction. Now negative 30 is not going to work here, because my angle needs to be between 0 and 360. So in order to make an angle positive, all we're going to do is, if going this way is negative, if I add 360 around, that's going to take me back to the same place I started with. So if I have negative 30 degrees and then adding 360 to take us back to the same spot, we talked about those periodic identities. If you add 360, it doesn't change the place that you add on the unit circle. Then that's going to give you 330 degrees. Okay, so instead of going negative 30, that's the same thing as going around the other way, and you get 330, which means that now this is actually going to have two solutions. It's going to be 30 degrees and 330. And if you check both those, cosine 30 is square root of 3 over 2, and 330, cosine 330 is also square root of 3 over 2. So I'm really using a reference angle here. Going up this way, 30 degrees, it's the same thing as going 30 down in that quadrant. It's just that I have to make sure that the angle that I have actually fits the original problem. It's got to be an angle between 0 and 360. Okay, this problem, an interval is given. However, we're noticing that it says 0 to 2 pi. That means that we want to write our answer in terms of radians. Okay, so now the first thing you want to do with these problems is you want to isolate the trig function. So we want to solve for cosine. So to do that, we're going to first subtract the square root of 2 the other side, then divide both sides by 2. So then we get negative square root of 2 over 2. Okay, now again, I mentioned that your table does not have negative values on it. That's okay. We're still going to use that as our main reference angle. So cosine is negative root 2 over 2. Let's look at root 2 over 2 first of all. Here it is on our table. In the cosine column, and we go back and we say that our angle is either 45 degrees or pi over 4. So let me do that in degrees, since this will be a little bit easier for you to see on the unit circle. Then we can convert them to radians later. Okay, so if we work with that, 45 degrees is our reference angle. So I know that that was here, that angle 45. That means that I have everything positive in the first quadrant. Now I don't have that, I have negative. So you got to think about what quadrants is cosine negative in, because that's the kind of value that I have here. So I'm going to do all students take calculus. Students means sine's positive, everything else is going to be negative. So therefore the second quadrant cosine's positive. Down here, take represents tangent, tangent's positive, everything else is negative. That means that The second and third quadrants, those are the ones that I have to draw my angles in because those are the ones that are going to be negative. Now, my reference angle is 45. The 45 is always measured from the closest x-axis. So I'm going to draw a line here. This is going to be 45 degrees. Draw a line there. This is going to be 45 degrees. So I'm using the 45 degree reference angle because I grabbed it originally off the table. That was normally 45. So it would be positive if it's over here in the first quadrant, but again, we want to make them in the second and third quadrant. So 45 going up and 45 going down. We have to express this as an angle. Well, between 0 and 360 we'll do first, then we'll convert them back over. Okay, now to get to here, what we're doing is this is 180 right here, and if we're going to go 180 minus 45, we're going to do 180 plus 45 to get the angles for each of those. Then we'll just convert them over into radians. We have 180 minus 45. So one answer is going to be 135 degrees. The other one is 180 plus 45, that's 225. Okay, so here's the two answers, 135 and 225. Now each of these are not considered correct because it's not between 0 and 2 pi. We need to convert these back over. So then you just use your conversion formulas. I'm not going to show that here, but you would use your conversion formulas to convert those back over. So here's the actual answers for the problem. That's between 0 and 2 pi. It's a radian measurement. 3 pi over 4 and also 5 pi over 4.